Hello, this is Professor Kim Nelson with the Jewelry Design Department at FIT. I'm going to do a tutorial this evening on organic surfacing. We've talked about it in class a number of times, but there still seems to be some confusion about how to approach more sophisticated final surfacing. Something beyond what I call, EFF, extrude, fillet, and flow, which we use a great deal for maquette modeling. When you're doing a organic surface, there are really mainly three ways to approach it. Okay, the first way would be to use a solid. Okay, so you can pick something off the solid menu. Okay, I'll just pull it here. Ellipsoid, for example, from center. Okay, we did this with the spoon exercise. It gives you an object, something like this, and then you would edit point or control point edit this object. To really edit it, you would have to rebuild it first, so because the points at this level are not very useful. So when you work with a solid like this, generally you're going to be doing control point editing. You're going to need to rebuild it. Okay, so something like this. Alright, and then no matter what you're doing, any of these advanced surface techniques require sub-object editing. Okay, that means control points are going to be involved. Whenever you're going to work with control points, you need to be aware of the orientation of those control points. In this case, they're rotated in spirals like tree rings from left to right, which does not suit any top view sort of top down sort of modeling. So I'm going to rotate it. Okay, that'll give me a bit better control over what's going on. And then you can take control points and edit this item any way that you see fit to get the results that you want. Alright, this is one way to create organic surfacing. Okay. It doesn't have a lot of available use in jewelry, generally speaking. It can. You can create some elegant forms this way, especially if you are going to use it for the top half, or if you're going to use the top half, I should say, of the object. Because as you know, most jewelry forms tend to be more or less flat backed. So if you're going to do something like this, let's say to have a solid first. Sorry. All right. Okay. Shell's a flaky command is going to cause me trouble. We'll decrease the thickness. Okay, it's still going to give us trouble. Okay, but anyway, you get the idea. you can create jewelry forms in this fashion. Okay? So that's one. Primitives that are modified. That is one way to create organic freeform geometry. Another way to create organic freeform geometry is to do a sweep. I think of these surfaces in two categories. Either a single surface, which is kind of like a sock or a half sock, if you can visualize that, or an object that has a top and sides, or top, corners, and sides. Okay, the top, corners, and sides approach is what you are used to viewing with the EFF, the extrude, fillet, and flow approach, where you extrude and fillet the corners. That is a top, side, and corner approach to something. Okay, and you can do organic forms that way, just not highly organic forms. But there are ways to do so. Anyway, going to show you a quick example of the more standard variation. I'll go ahead and draw a cross section quickly. I'm not terribly picky about what I come up with here. There. Kind of a basic cross section. And I'll make a copy of it. And place it out here somewhere. And then I'm going to make some rails. These are section rail sorts of items. And, you know, I'll make it a little more organic than that, so hold on one second. Just drawing a quick sample rail. Okay, so one example of this approach would be a single rail sweep. Select the rail, select your cross sections. And there, okay? This is your basic kind of a sock. If it didn't have a bottom on it, it's what I would call a half sock, okay? It's a fine way to create surfacing. One rail sweep is done when you want to have control of the cross sections, and it's a fairly simple flow of the piece that you want to do, when this will suffice for the amount of detail that you need. If that won't suffice, say, for example, you have something happening different on the other side. I'll just use gumball for this. Okay. Then you would need to have a bi-rail sweep. This allows you to change the profile of the piece and dictate the profile in much more detail and the cross section. Once again, fine way of making surfacing. That's a bi-rail sweep. And if you need even more control than this, you would do the surface and curve network. That's when you want to control another direction or dimension of the lofted surface. So actually we'll do something simpler. So if you simply wanted to have this and we'll have it rise up in the middle. If you're going to do something like this, then you would, if you want this level of control, the basic profile, shifts in elevation, and cross sections, you would do surface from curve network, which can really use an unlimited number of rails and sections. Now it's going to cause a problem. I was going to correct it, but I might as well show it to you. Notice how it becomes very strange at the bottom. It's because I have a closed cross section. Remember, surface from curve network cannot make a poly surface, so those corners will be problematic. Again. Okay. Once again, a fine way to make a surface. Gives you pretty much the ultimate control, level of control, for this approach to organic surfacing. So, so once again we have, let's swap the order of these two. Single rail, bi-rail, surface from curve network. Okay, so this is the sock or half sock sort of swept surfacing. It gives you the entire piece or whatever section of the piece you're trying to create in one surface or in one command. This is likely a poly surface. Well, it has a bottom, so I know it's a poly surface, but yes, it actually, here's Rhino doing kind of what I'm going to talk about next on its own, giving it kind of a top and side approach. It decided that this was too sophisticated for a single surface and broke it into a poly surface. This will just, it did the same thing here, actually. Okay. This, by the way, is one of the challenges of using any of the surfacing techniques other than surface from curve network, is that even though it looks like a single surface, it may not be, and you want to be aware of that. But okay, enough on that topic. So we have working for the solid that we modify. We have doing various lofts or sweeps. Okay. Actually, I haven't really discussed a loft. I'll take a minute and do that. I rarely use it except for to fill in a blank area. Okay. But a loft just uses curve information in one direction, either the sweeps, either the rails or the sections. So and Rhino will decide to do what to do with that. Now this is straight sections. Normal, it'll actually create a soft surface that connects all of these. Loose pays less attention to the curves and gives you a softer surface. Tight pays very close attention to the cross sections and can give you a slightly more, not the cross sections, but the rails, the curves, can give you a slightly more pinched effect. Okay, and then straight sections, and then uniform and developable. Developable is a surface that you can lay out in a flat pattern. It usually gives you very crazy results. We don't bother with that. Uniform is like you rebuilt the surface to have a uniform dispersion or displacement of control points, placement of control points. So when this is done and you turn on the control points, you should have a fairly even distribution of those points. Okay? But you obviously don't have very much control over the sectional data in this direction, only this direction. And the same thing is true going the other way. If we did a loft and we went from here to here, it's basically going to give you a straight section, a straight piece, because there's nothing in between. They're both the same cross section. So normal is going to look the same. Okay? But yeah, that's a loft. So lofts and sweeps. Okay? I'm going to actually have these examples out as well of basic lofted surfaces. Okay. You will see these techniques used a great deal in Rhino tutorials on the internet and around. They're kind of the bread and butter of organic modeling. The challenge is when you're trying to do something that's either sophisticated, well, I'll just say something you need to have more control over. If you need to have a lot of control over what you're doing, all of these can become labor intensive, trying to, use history and update curves and move things around to try and get what you want. It's possible. I do it all the time. But usually for more complicated pieces or elements, because I wouldn't rarely surface a whole piece in one step, or so I should say section of a piece or element. Usually I'm going to use something else. Usually I'm going to do the top and sides, or tops, corners, and sides. And the approach to that, here's one of my typical kind of squiggly things that I do for this sort of tutorial. This is going to look familiar to you. Usually, I start by doing a drawing, of course, of what I'm going to do. Being aware that any points will have to be handled separately. What I need is two related curves that run kind of more or less parallel to each other. What I would normally view as a rail situation in a swept surface. Okay? You don't have a lot of control creating a surface between these two. And the surface I'm going to create will be the top surface. I'll create the top surface first. It can also end up being used as a bottom surface, which we will take a look at. So the fastest way to make a surface here is a loft, but I'm going to get very skewed surface detail. The isocurves, if you see them, they're very slanted and sheared, skewed. When you're doing control point editing, which is what all of these techniques require you to do, even the sweeps, when you're drawing those cross sections and rails, you're doing a lot of control point editing. When you're going to control point edit, sub-object edit at the surface level, using surface geometry, I should say, the grain of the surface is really important. Can't think of a better word than grain, so I'm going to stick with it. You want the surface to basically be kind of a canvas of equally placed, sensibly oriented control point information. And that's very hard to get using a lofted surface. It doesn't give you enough control. So I usually create these using a bi-rail sweep or a surface and curve network. But usually it's a bi-rail sweep. not sure what it's seeing that it wants to grab, because that's the end right there. Alright. Ideally, both of these curves should have the same control point math for what we're going to do. And you'll see that these do. They're 13, 4, which is fine. I'll leave them where they are. When I drew them, I made them the same. So you want these two rails or outlines, profiles, pick any word you want there, to have the same control point count and math. Alright? Going to do I'll make these on the same layer as the rest of the drawing. Going to make a surface, bi-rail surface. Bi-rail sweep. Rail 1, section, section. Now it's a flat surface. It's a planar surface. That's an important thing to note. If I wanted to, class, I could simply pick these 4 curves and make a planar surface. Fills the same area. But its control points are useless to me. Well, if you can see those, but it has 4 control points on the outside edges because it's a square surface. Okay? Completely useless to me because I'm going to want to go in and control this. So I want a surface I can control, that I can work with at the sub-object level, at the control point level. So rail, rail, section, section. The thing I like about doing a bi-rail sweep here is that once again I have the same skewed surface, but I can add a slash. So usually I'll come into the middle and I'll add a slash that looks more or less perpendicular to both curves, both rail curves. And you see that gives me iso curves going in a more proper direction, and I will do this as many places as I need to direct the flow of those iso curves in a way that makes sense to me. Because these will be my canvas. These will be my clay. If they don't make sense, I'm going to be struggling. Hit OK. Problem is now I have a surface that makes a certain amount of sense, but the other thing I want is I want evenly placed points. That's important to me. I want an even distribution of points. Okay, so I will go ahead and achieve that now by rebuilding. Right now it's 67-2, 3 and 1 as far as the degree. Third degree means it's organic with a whole lot of control going along its length. 2 points with a first degree curve means, or first degree surface means it's a flat surface with a control point at each side. I don't want that. So I think I can handle this entire length probably with something in the vicinity of 24 points. And I want 5 points across. 1, 2, 3, 4, 5. That'll give me a little bit of control over the form here and a center row of points. I like third degrees for surfaces. I always say fourth degree for curves, but when I'm surfacing, I do prefer Rhino's default of third degree surfacing. And I'm going to hit OK. And you'll see that gives me a very consistent surface. If I turn on the control points, they're very predictable. They only get a little bit crazy at the end, where Rhino always adds that separate, extra row as an anchor. And I can delete those if I want to, but I leave them usually. They don't get in my way with surfacing near as much as they do when I'm drawing. Okay? So there's my surface. This is my top. In case I want it for a bottom, I'm going to Control Copy to Clipboard, Control V, paste, so Control C, Control V. And I'm going to put this on a layer for storage where I can get it back later if I want it. Okay? So that's my top. Okay? My sides I will deal with more, well, I can show you how I will generate them, but you wouldn't normally generate them at this point, but for the continuity of this video I will do it. My sides are going to be extrusions. Okay, so I can just extrude, and I don't want to use the curve. I want to use the edge of this surface. Now in the video for the bypass ring of mine, I didn't do that, and there was a good deal of shearing in the surface. I didn't worry about it because I knew what I was planning to do, but it's poor form for many things that you'd want to do. One side only. And I might as well select both sides and do them together. Okay. The importance of extruding from the surface is you'll notice that the iso curves, the control points, all line up. That makes your life so much easier. These are extrusions. Before I can turn the points on, I have to explode them. That's a fluke in Rhino 5. I don't know why they require you to do it, but even though these are each single surfaces, an extrusion is considered kind of a compound object, and to access anything in the surface itself, you'll have to explode it first, which is what I've just done. There. Now I can turn on the points, and you'll see that the points here are lining up with the top surface. That's very important. And then generally how this system works, and we'll go into much more detail in another video, but generally how this system works is I will grab the top rows of the side surfaces, lower them, and then match surface. And that will give me sides and a top. That are quite smooth. Okay? So this would be another method of getting organic surfacing when you want to have more control than some of these other methods allow. Okay, so that's it for this video. Thanks so much for watching.